Hello everyone, I'm Yukang, presenting our process report for the State Space Explorer. This project was built for Innova Technologies to support the Australian Navy's mass training system, where our final presentation focused on the finished software. Today we will discuss the process, how we planned, collaborated, and refined the solution using Scrum. Our challenging was huge. The MATLAB system contains around 10 to 12, 20 possible states. Far too many to test directly. We had to design an algorithm that could learn from a small number of samples and still predict the entire space efficiently. Over 12 weeks, our team combined agile methods, strong communication, and technical innovation to meet that goal. These slides outline what we will cover. First, I'll explain our Scrum framework, how roles rotated and meetings were managed. Next comes to communication, how how tools uh how tools like WeChat and Microsoft Teams supported quick updates. We will then discuss how requirements evolved through the Titan competitions and how we validated progress using performance scores. After that, we will show the tools and the testing workflow, including Python, KD-tree, and Titan. Finally, we will reflect on what worked well and what we will change in the future projects. The focus today is on teamwork and iteration.
To set the stage, the mass system protects ships from missiles using countermeasures. Testing it in reality is risky and costly, so simulation is essential. Our client asked us to model the system's entire state space, roughly 10 to the power of 20 combinations, clearly impossible to compute exhaustively. We tackled this using smart sampling strategies and interpolation algorithms, running on the Titan platform for accuracy scoring. This context shaped every design choice, from algorithm selection to sprint planning. We followed an agile Scrum approach throughout the semester. Each sprint lasted roughly 2 weeks, and the Scrum Master role rotated so that everyone gained leadership experience. Weekly online meetings kept progress visible, while client check-ins ensured alignment with Innova. Daily stand-ups happened through our WeChat group to handle quick issues. This structure gave us accountability and adaptability, important when competitions or deadlines changed.
Flexibility was our greatest strength. We adapt quickly when teacher introduced new competitions or scoring changes. However, meetings were sometimes inconstant, leading to slower decisions. In future projects, we would schedule regular stand-up and keep writing sprint summaries to stay aligned. We relied mainly on WeChat for condition and updates, plus weekly calls for complex topics. This gave us faster feedback and accessibility, but made it difficult to track older decisions. Next time, we'd complete WeChat with task tracking tools like Trello for better visibility. Our requirements came from Titan computation, description, and slight qualification on Microsoft Teams internally. Success meant basic production. Later, we add runtime and auxiliary growth. This evolution reflects the real engineering practicals, adjust the scope as understanding depend.
Middle semester, Titan included spherical and cylindrical modes, uh, forcing us to reflect algorithm. We modelize the code to handle new data types quickly and optimize the runtime using vectorized operations. The adaptability show the strength of age practice in academic projects. Our definition of done evolved from simple foundational to optimize accuracy and uh, efficiency. We measured completion using Titan's scores targeting under 2 minutes runtime and above 19% accuracy. This clear method has maintained focus and momentum. We use Python for certificately ISCO systems, non-PY, SAN-PY, and select learn handle the most calculation VS Code and the PySim were our main ideas with GitHub for vision control. Uh, if extend, we explore hybrid C++ mode for GPU acceleration.
Testing was interactive upload to Titan. Analyze the score, refine, and repeat. Locally, we validate logic and runtime stability. This loop gives rapidly feedback and guide our optimization efforts. And next page. Our process starts slow due to the learning curve, but sprint improved steadily from 21 to 45 story points. We made 142 comments and over 3,500 lines of code. These metrics reflected consistent efforts and teamwork. And next page. We maintain stabilities with GitHub branching. Each member works on featured branches and use pull requests for peer review. Weekly merges ensured integration without complex and promoted shared code quality.
Documentation was minimal, mainly through code comments and shared algorithm notes. This worked internally, but for future scalability, we established a wiki or documentation hub to store knowledge systematically. Our strengths include adaptability, accountability, and collaborative spirits. We learned quickly and supported one another in solving complex issues. The teamwork dynamic helped us deliver efficiently under pressure. We lacked consistent meeting schedules and formal documentation. Scrum rotation also became unclear during busy periods. We plan to use tracking tools and fix routines in future projects. This project taught us that early optimization and domain knowledge are crucial for performance. Collaboration outweighed individual expertise, and iteration was key. Our next steps would be GUI development, GPU acceleration, and cloud integration. That's all.